In question 51, we have two situations. The first one is where energy is conserved, and then the second one, we have kinetic friction introduced. Let's solve the first one. We have our spring compressed, therefore we talk about elastic potential energy. That elastic potential energy turns into kinetic and gravitational potential energy for our object. We know that our kx squared over 2 is the formula for elastic. mv final squared, that's going to be initial. mv final squared over 2 plus mgh. H is given to be 1, g is 9.8, mass is given to be 2 kilograms. We need to figure out the speed of the package when it reaches the truck, when there's no friction. That's pretty easy. So we have our 500 over 2 times 0.3 squared minus 2 times 9.8 times 1 equal 2 times v final squared over 2, very conveniently. So 250 times 0.09 minus 19.6 equals 2.9, and it equals to v final squared. So then root of 2.9 gets me 1.7 meters per second. In B, we're looking at whether our box will make it to the top at all. If there is force of friction, there is a 50 centimeter long sticky spot. Let's look at what we have to begin with. Kx squared over 2, which is 250 times 0.09, 22.5 joules of energy we have to begin with. That's our elastic potential energy. How much will friction eat up? Friction will be mu mg times 0.5 for distance, cosine of 180. That will be the work done by friction. So 0.3 times 19.6 times negative 1 times 0.5. So negative 19.6 times 0.15. That gets me negative 2.94. Gets me 1956 joules of energy is left by the time our object gets over here. We need 19.6, which I get from mgh being 2 times 9.8 times 1, that's 19.6. So this is how much energy I need. This is how much energy I have left over. And the answer is it's not going to go up that ramp because of friction. There you go.